Good morning all. In this session, we will discuss different types of heat exchangers. Heat exchange between fluids is an operational requirement in many systems ranging from household refrigerator to modern aircraft. A device used to perform the same is known as heat exchanger. By definition, heat exchanger is a device that transfers heat energy from a hot fluid to cold fluid with maximum rate and minimum cost. They are generally used in systems with heating and cooling applications like air conditioning systems, chemical and food processing industries, power plants, etc. Some of the examples of heat exchangers are condensers, boilers, preheaters, intercoolers, radiators, evaporators, superheaters, economizers, and so on. Figure shows a familiar heat exchanger used in automobiles, that is the radiator, which is used to dissipate heat contained in the engine coolant to the atmospheric air. Even though purpose is same, heat exchangers differ in their operation and constructional features. Heat exchangers are classified based on nature of heat exchange process taking place in the heat exchanger, relative flow direction of fluid in the heat exchanger, design and constructional features of the heat exchanger, and physical state of the fluid in the heat exchanger. Based on nature of heat exchange process, heat exchangers can be classified into direct contact type and indirect contact type. We start with first one, direct contact heat exchangers. They are also known as open heat exchangers. These are heat exchangers where heat exchange takes place by direct mixing of hot and cold fluids. It involves both heat and mass transfer simultaneously as the streams mix together. They are preferred when mixing of two fluids is either harmless or desirable. Example, cooling tower. Cooling tower is a system where hot water is cooled by directly spraying it over a flow of cold air. Another example is direct contact condenser. In direct contact condenser, steam mixes with cold water, condenses and form warm water. In these examples, heat exchange between the two fluids takes place by direct mixing. Next is indirect contact heat exchangers. These are heat exchangers where heat transfer takes place without the mixing of hot and cold fluids. This can be achieved by two means. Either by using a high thermal conductivity wall which physically separates the hot and cold fluid through which heat transfer takes place, or by using a medium that receives and stores heat from the hot fluid and transfer it to the cold fluid. Based on this, indirect contact heat exchangers can be classified into two as recuperators and regenerators. Recuperators are common type of heat exchangers. In these type of heat exchangers, hot and cold fluids are separated by a high thermal conductivity wall through which heat transfer takes place. In the heat exchanger, hot fluid and cold fluid will be moving and they are physically separated by a high thermal conductivity wall as shown here through which heat transfer takes place. Unlike recuperators, regenerators consist of a porous solid medium with large storage capacity known as matrix. This solid matrix receives and stores heat from the hot fluid which is then transferred to the cold fluid. Based on the type of matrix used, we can classify regenerators into static type and dynamic type. Regenerators are mainly used in gas turbines to recover heat from the exhaust gas. This is a schematic representation of static type of regenerator. In this type, the matrix is stationary. When hot fluid flows through the matrix, heat is stored in the matrix, and this stored heat is transferred to the cold fluid when cold fluid is made to flow over this matrix. During the first phase of the operation, hot fluid flows through the matrix in this direction and heat is stored in the matrix. During the next phase, cold fluid flows through the matrix and takes away the heat stored in the matrix. Valves of hot and cold fluids are operated to achieve this particular working. Due to this nature of operation, heat transfer associated with static type regenerator is intermittent or non-continuous. These are the points pertaining to static type regenerative heat exchanger. On the other hand, in a dynamic regenerator, matrix is movable. Figure shows a rotary regenerator where matrix is in the form of a drum that can rotate about an axis. Here, hot fluid flows through one half of the drum and cold fluid flows through the other half. Hot fluid flows in this direction and cold fluid flows in this particular direction. Heat stored in the drum when hot fluid flows during the one half revolution is transferred to the cold fluid in the next half revolution due to the rotation of the drum. Here in dynamic regenerator, heat transfer is continuous. These are the points pertaining to dynamic type regenerative heat exchanger. Based on the relative direction of fluid flow, heat exchangers can be classified into parallel flow, counterflow, and cross-flow heat exchangers. In a parallel flow heat exchanger, both hot and cold fluids flow in the same direction within the heat exchanger. Here, hot fluid flows through a pipe in one direction, and cold fluid, which surrounds the pipe, flows in the same direction that of the hot fluid. Due course of its flow, heat transfer takes place from hot fluid to cold fluid through the pipe material through which the hot fluid is flowing. Consequently, hot fluid temperature decreases and cold fluid temperature increases. If we plot the temperature variation of the fluids along the length of the tube of the heat exchanger, we can see that hot fluid temperature decreases from TH1 to TH2 along the length of the heat exchanger, whereas cold fluid temperature increases from TC1 to TC2 along the direction of flow within the heat exchanger. In parallel flow heat exchanger, both hot and cold fluids enter through the same side of the heat exchanger. Also, they flow in the same direction through the heat exchanger. As the fluids flow in the same direction, parallel flow heat exchangers are also known as co-current heat exchangers. The schematic representation of parallel flow heat exchanger in front view, side view, and also its temperature profile is available in this slide. In a counterflow heat exchanger, both hot and cold fluid flows in the opposite direction through the heat exchanger. Hot fluid flows in this particular direction, whereas cold fluid enters through the opposite side and flows in a direction opposite to that of the direction of flow of hot fluid. Due course of its flow, heat transfer takes place from hot fluid to cold fluid through the tube wall. When we plot the temperature profile, we can see that hot fluid temperature decreases from TH1 to TH2 in the flow direction, whereas cold fluid temperature increases from TC1 to TC2 in the flow direction. We have seen that in a parallel flow heat exchanger, both hot and cold fluids move in the same direction within the heat exchanger. Whereas in this case, in a counterflow heat exchanger, hot fluid and cold fluid moves in the opposite directions. This is also clear from the temperature profile. Here hot fluid is dropping its temperature in this direction, whereas cold fluid is gaining its temperature in this particular direction. Next is cross-flow heat exchanger. These are heat exchangers where the direction of flow of hot and cold fluids are normal to each other or at right angles to each other. They are of two types. In type 1, one of the fluids is confined to flow through tubes, whereas the other fluid flows freely over the tubes. Here, fluid A is confined through the tubes, so stream of fluid A cannot be mixed, whereas fluid B is free to flow over the tubes, so fluid B can be mixed. This type of cross-flow heat exchanger is known as cross-flow heat exchanger with one fluid unmixed. In type 2, in addition to the confinement imposed on fluid A, fluid B is also confined to flow through passages made by placing plates as shown in the figure. Here, fluid A as well as fluid B, that is both the fluids, are unmixed. This type of cross-flow heat exchanger is known as cross-flow heat exchanger with both fluids unmixed. Automobile radiator, Condenser in air conditioner are some of the examples of cross-flow heat exchanger.